In our fifth example on practice test B of acids and bases, we're given the pH or pOH of a solution and are being asked to calculate hydrogen ion or hydroxide ion concentrations. Again, let's review our familiar equations. Knowing that pH is found by hitting negative log of the concentration of the hydrogen ion in molarity units, we can manipulate this equation to find the hydrogen ion concentration by taking 10 raised to the power of the negative pH value. These two are the same equation, just solved for different variables. pH, negative log of hydrogen ion, and to change that around to find hydrogen ion, we simply hit 10 raised to the negative pH. That same relationship can be found for pOH. If the power of hydroxide ion is found by taking the negative log of OH negative, we can manipulate that equation to find the concentration of the base ion by taking 10 raised to the negative pOH. And let's remember, pH and pOH, when added together, give us the top of our scale of 14. These equations prove handy as we're pulling out the required information of Objective 5. For instance, with our first question, we're being asked to calculate the H+. So it's coming directly from the pH, but again we'll have to flip pOH into pH first before we would find hydrogen. Let's model that. Letter A gives me pH directly. So does letter D. 10 raised to the negative pH will solve for the hydrogen ion. But notice letter B and letter C give us pOH. We'll have to 14 minus to find the pH before we actually hit. Let's do an example. In our first example, we see a pH of 2.5. On my screen, I literally hit 10 raised to the negative 2.5 equals, and I get the concentration of the hydrogen ion, 0.0032 molar. 0.0032 molar, 10 raised to the negative pH. However, in letter B, I'm not given pH, but I'm given the base, pOH. But that's easy enough to fix. 10 raised to the negative, parenthesis, 14 minus 10.8. And notice what I'm doing. I'm raising it to the power of pH, but letting the calculator do the subtracting for me. What I'm doing inside the parenthesis is flipping pOH into the pH I need to calculate hydrogen ion. So 10 raised to the negative 14 minus pOH equals, and I find 6.31 times 10 to the negative fourth. I'll write that down for us. 6.31 times 10 to the negative fourth molar units. We'll do the same for letter C, the same pathway. 10 raised to the negative 14 minus 6.0, flipping the pOH into the pH we need to find hydrogen ion. And that gives us 1 times 10 to the negative eighth. 1.0 times 10 to the negative eighth molar units. And the letter D, since we're given pH directly, H and the hydrogen ion match directly, we'll simply hit 10 raised to the negative 13.6, pulling out the hydrogen ion value of 2.52 times 10 to the negative 14. 2.52 times 10 to the negative 14th molar units. Again, my screen showing 2.5118, so I'll just round 2.51 times 10 to the negative 14th. So with our first series, we needed pH to find hydrogen. Now notice in the second example, we're being asked to solve for hydroxide. To find hydroxide directly from the pOH. The direct calculations for hydroxide come from 10 to the negative pOH. So B and C can be hit directly. It's the letter A and letter D that give us pH. Notice the mismatch. If we want hydroxide, I cannot get there directly from a pH. But Easy enough. We'll let the calculator do the work. 10 raised to the negative, parenthesis, 14 minus 10.8, flipping the pH into a pOH. And we find 6.31 times 10 to the negative fourth molar units. 6.31 E negative 4. So we'll record that. 6.31 times 10 to the negative fourth molar units. Letter B, we said, can hit direct. Hydroxide is found directly from pOH. We hit 10 raised to the negative 13.6. And our screen says 2.51 times 10 to the negative 14th. Same strategy for the letter C. 10 raised to the negative 2.5. And we find 0.0032 molar. And letter D, pH given as 6.0. Again, an indirect, we have to do 14 minus to flip pH to pOH. 10 raised to the negative 14 minus 6 gives us 1 times 10 to the negative 8th molar units. In the first series, we needed pH to pull out hydrogen. In the second series, we needed pOH to pull out hydroxide. And there is the fifth objective, our A+.